Unit 6 D through F test review. So we have the first one, complex fractions is when you have a fraction divided by another fraction. So when you have a fraction divided by another fraction, you can just treat the middle fraction, the biggest fraction line, as a division. So you have a fraction divided by another fraction. So when you have a division of two fractions, what you're going to end up doing is keep the first fraction the way it is, change the big division to multiplication, and flip the second. Now, next thing I think about is what are each numerator and denominator, and they're all monomials. So with monomials, you can simplify with monomials. If you want to you can either simplify straight out how it is now. Any numerator can simplify with any denominator. They're monomials. So we have a 2 divided by 2, which is 1. We have x divided by x squared, which divide each by x. You get 1 in the numerator and x in the denominator. Then you can multiply across. Straight across the numerator is 1. Straight across the denominator is x. With monomials, you can multiply straight across right away and then simplify. So it would have been 2x over 2x squared and then simplify to 1 over x. Moving on to number 2. So we have, assuming no denominators equals 0, that's always the case in math. No denominator can ever equal 0, so that doesn't really matter for you when it comes to simplifying this problem or finding which expression is equivalent. So you look at it, we have a fraction here. There is a subtraction, but it's one fraction divided by another fraction. So in that case, we can just jump, like in problem 1, we can just jump straight to keep that first fraction the way it is. The middle is the fraction line. It's always the longest one. It's a little bit longer in the middle, so change it to multiplication. And the denominator, flip it. So the denominator becomes the numerator becomes the denominator. And we have 15 minus x. I'm going to rewrite that so it's the x first. So it's a negative x, because it's a negative x, and the 15 is positive, so plus 15. The reason why I rewrite that is because usually we have the x term first, biggest exponent, so that's 1, and then 15 is 0 as an exponent. X is 0. Now when we're looking at simplifying this, I see a monomial in the numerator as a factor, and a monomial in the denominator as a factor. So monomials can simplify with monomials. They don't have to be exactly the same, but the variables have to be, the bases have to be the same. So we have, coefficient-wise, we have 3 over 9, so 3/9 reduces, divide by 3, divide the 9 by 3, so 3/9 reduces to 1/3. X to the 5th over x, you divide numerator by x and the denominator by x. So this is, it was 9 times x, now it's 3 times 1. Over here, we have something special going on here. We have the numerator, this binomial is x minus 15. This denominator is a negative x plus 15. That's a binomial also, so binomials can simplify with binomials. Now, if you notice, they're opposite. Each term is opposite. So in that case, if you take a greatest common factor of -1 out of, say, the denominator here, divide each term by -1, you'll get x minus 15. So instead of this denominator, we're going to replace it with this denominator here. And by doing that, you have a factor of x minus 15, that's a binomial, and x minus 15. So that's 1 over 1 if you'd like to write that. And now let's rewrite what we all have here. 1 times x to the 4th is x to the 4th over 3 times 1 times -1 is -3. When it comes to negatives, you can slide that up to the middle or to the top, doesn't matter. If you're looking at which answer is equivalent, you have A over here. Number 3, which expression is equivalent? Number equivalent, you can always take the answer choices and substitute numbers in for the letters to see which one matches up. So you can do that in the calculator, store a number. So we have another fraction divided by another fraction. So again, it's the same as the last two. Keep it, change, flip it. And the next problem we'll deal with when there isn't a fraction divided by another fraction right away. So looking at each numerator and denominator, we have monomials. So any numerator can simplify with any denominator as long as it's a monomial. In this case, we have a squared in the numerator, a squared in the denominator. Divide them both by a squared, you get 1. A squared divided by a squared is 1. 25 divided by 5 reduces to 5 over 1. And there's a b left over here. So we have 1 times 5 in the numerator over 1 times b times 1 is b. So we have 5 over b. That's one of our answers. And now be very careful. Anytime this gray banner appears on our assessments or on the SOL, you got to choose more than one answer. So the very first thing we did was to keep, change, flip. So let's look for that answer, a squared over b to the 5th, or b times 5 times 25 over a squared. That's a over here. And let's see if there's anything else that would be equivalent. So if I just simplified, let's see, if I did the a squared, then it'd be 25 over 5b, which is actually e over here. So if I just simplify the a squareds, if I just simplified 25 over 5, that'd be 5a squared over ba squared. And that's 25, so that's not right. And over here is not correct either. So it's just these two. This is actually supposed to be over here for C. All right, number 4. So now we have a fraction adding another fraction divided by a fraction adding a fraction. So here we have to get these fractions together. So your first goal is to get a fraction divided by another fraction. So we need to get this numerator together. So how you do that? You get like denominators. We have a squared as the denominator and 2 as the denominator. The easiest common denominator there is 2a squared. So let's multiply the second fraction by a squared over a squared. Always multiply by something that's equivalent to 1. That doesn't change the value of the problem, multiplying by 1. And let's multiply the first fraction by 2 over 2. That's why we can multiply by different things to different fractions, because we're multiplying by something that's equivalent to 1. Alright, let's put this together. 2 times 9 is 18. Plus 1 times a squared is a squared. And since we have like denominators, we can join it as one fraction, so 2a squared. Don't think about simplifying this. Don't simplify. 18 plus a squared is one binomial, so binomials only simplify with binomials. Monomials only simplify with monomials. They don't simplify together. So that's our numerator. Look in our first fraction, and then divided by, we have 3/4 plus 4 over a. So you're looking at the denominator, you got to get, looks like 4a would be the easiest. So multiply the second fraction by 4 over 4. Multiply the first fraction by a over a. It's going to get a little sloppy over here, but we have 3a plus 4 plus 16 over 4a. I'm going to continue down in this blank spot down here. So now we have a fraction divided by another fraction. So now we can do keep it, change it to multiplication, flip it. So we have 18 plus a squared over 2a squared. Change it to multiplication, and 4a, move denominator to numerator, numerator to denominator. Alright, any binomial can simplify with a binomial, but they have to be exactly the same. So 18 plus a squared, 3a plus 16, can't simplify. There's no greatest common factor in either one to take out either, so there's nothing there to simplify. But fortunately we have a monomial numerator and a monomial denominator that coefficients can simplify. 4 over 2, divide 4 by 2, 2 by 2, and also the a terms, a's here, a factors. Divide a by a, 1, divide a squared by a, you get a. Alright, let's rewrite what we have here. We have 2 times 18 plus a squared, and And we have 1 times a, which is a, times 3a plus 16. Alright, I'm okay with this answer, so if you have that as an answer, awesome. If you want to multiply it in because, well, I guess that's the answer choices that's going to be up here, you can certainly do that. Because it's multiple choice, you're probably going to want to do that, so then you can get the answer. So distributing the denominator to the a, and unfortunately, it just happens to be the answer that I covered up there. Alright, let's move on. Alright, we have a keep it, change it, flip it again. So let's get like denominators. So it looks like the numerator is multiplied by 3 over 3. And that'll give us 2 plus 3. Let's just change that. So 2 plus 3 is 5. Let's just make that easy ourselves. Over 3x divided by denominator. Let's see, we need to get 2x as a denominator. So that's going to be 16 minus x over 2x. So now we have a fraction divided by another fraction, so keep it, change it, flip it. 5 over 3x times 2x over 16 minus x. You can rewrite this 16 minus x as negative x plus 16. The reason why I'm not going to do it here is because none of the other numerators have a binomial, so I know I can't do anything with simplifying here. But you certainly can move it. You can take out a negative 1. Keep practicing that because you're gonna see that more often. So we have monomials, 2x over 3x. So I have the monomial x divided by x. That's 1, 1. 5 over 3 can't simplify. 2 over 3 can't simplify. The 16 minus x, that's a binomial. That does not simplify with the monomial, so we cannot simplify the 2 over 16. You can't break it up. Multiply straight across. 5 times 2 times 1 is 10 over 3 times 16 minus x. And that's your final answer. Next one. So we have alright, so we have number 6. We have a fraction subtracting another fraction and a fraction adding another fraction. First thing you got to do is get a fraction divided by another fraction. So let's get to it. Looking at the numerators up here, we have to get like denominators. So looks like the easiest way is y times x plus 2 is going to be the easiest. So x plus 2 over x plus 2. So that numerator is going to be 9y. We have a negative 1 times x is a negative x. Negative 1 times 2 is a negative 2 over y, and it doesn't matter which way you write this. Usually a monomial comes first when you go factor. So the y times y plus 2, and we're going to put that to make that denominator. Looks like if you just multiply the first fraction by 6, you get 6y as a denominator. So it's going to be over 36 over plus x plus 2. Sorry, that's a little sloppy. 36 plus x plus 2 over 6y. And that's going to end up being 38. So when I keep it, change and flip it here, we'll see that. So we have 9 minus x minus 2, or 9y minus x minus 2 over y times x plus 2 multiplied by 6y over 36 plus 2 is 38 plus x. Alright, so we have a trinomial in the numerator here, no greatest common factor. Monomial, we have a monomial and a binomial, and no greatest common factor, no way to simplify that, factor that. So we're just going to look to simplify now. So a trinomial has to simplify with a trinomial. There's no other trinomials, so nothing to simplify with. We have a monomial here, 6y, and you have a monomial y. So monomial, simplify with monomial. Y divided by y is 1 over 1. Binomial, there's no binomial in the numerator. So this is all we can do simplifying wise. It's not a whole lot. So I'm going to rewrite it down here. We have 6 times 9y minus x minus 2 over 1 times x plus 2 is x plus 2, and 38 plus x. And that is your final answer. It is not a pretty answer, but it is our answer. If you would like to multiply it out, you certainly can. But when you multiply it out, you have to have the right answer. So the more math you do, the more likelihood you're going to get it wrong. But you're more than welcome to multiply it out. There's nothing wrong with it, as long as you do it correctly. All right, moving on. Number 7. So the first thing I'm going to do here when it comes to solving rational equations is factor the denominator. My first goal is to get like denominators. So I want x squared minus 25. We can factor that in x minus 5, x plus 5. And when I do that, I get to see that I have x minus 5, x plus 5. I have an x minus 5 and an x plus 5 here. So getting like denominators is not going to be that difficult. All we're going to have to do is, since we have an x minus 5 here already in the first fraction, multiply by x plus 5. And remember, always multiply the numerator by the same thing as the denominator. Every term has to have like denominators. So the second fraction here, term, has x plus 5, so let's multiply by x minus 5. Now let's put this all together. So I have x plus 5 times 1, which is x plus 5, minus 1 times x is a negative x, negative 1 times negative 5 is positive 5, equals x squared plus 3x minus 18. So I'm just dropping the denominators. The reason why you can drop the denominators is if I were to just multiply by the denominator, x plus 5 and x minus 5, multiplied each term by that, it cancels out the denominator. As long as you multiply both sides of the equation by the same thing, you're not breaking any math rules. So if I multiply each fraction by the denominator, which are all like denominators, it's going to end up canceling them all out, which will end up giving us what's in the black here. So now, once we get like denominators, drop the denominators and solve the numerator. So we're looking at solving it here. We have, I can see x minus 5, or x minus x cancels. I have a 5 plus 5 is 10, equals x squared plus 3x minus 18. Subtract the 10 over. The reason why I'm doing that is because I see an x squared term. Anytime you have x squared terms, quadratic, you should be thinking factor to solve or quadratic formulas. So in order to either factor or use quadratic formula, it always has to equal 0 the equation. So that's why I subtract 10 over. So now, let's see if I can quickly factor. So the a term is 1. So what two numbers multiply to negative 28? So that's a c. That'll add up to 3, which is the b. And that is plus 7 and minus 4. 7 times negative 4 is negative 28. 7 plus negative 4 is positive 3. And the reason why we're going to factor here is because when you have factors, all you have to do is figure out what number makes each factor 0, because that's what it equals, 0, and those will be your solutions. So if I take this first factor, and what number would make the x 0, or make that factor 0? And if you don't know off the top of your head, this one might be easy, but just so you know, always set it equal to 0, the factor, and that'll solve it. And x minus 4 equals 0, add 4, add 4. So it's negative 7 and 4. And so if you substitute negative 4, let's say, into this here, you get negative 4 minus 4 is 0. And 0 times 11 is 0. And the same thing with negative 7. Negative 7 plus 7 is 0. Negative 7 minus 4 is negative 11. 0 times negative 11 is still 0. So that's good. You should always make sure that the solutions are not extraneous. So substitute -7 in, just substitute in the denominator, because no denominator can never equal 0. So -7 minus 5, so, okay, that's not 0. -7 plus 5 is not 0. -7 squared minus 25 is not 0. So -7 is a good answer. And 4. 4 minus 5 is not 0. 4 plus 5 is not 0. 4 squared minus 25 is not 0. So both of those are good answers. So we have 4 and -7, which is A. Alright, moving on to the next problem. Okay, so we have the same thing. Let's factor. So factor that denominator first. So we have A times A minus 2 is the factor of the first denominator. The second denominator is no factor there. A is just monomial, there's nothing to factor. And the last denominator, greatest common factor. Always think greatest common factor first before you try factoring any other way. Okay, now the next thing we're going to do is look to see what would be my common denominator. So I have A times A minus 2 and A times A minus 2. All the denominators already have an A in them, but they don't have an A squared. 2 of them do, but the third one, the middle term here, does not. So we multiply that middle term by A minus 2 on numerator and denominator. Now all the denominators are the same. And when that happens, you can just drop the denominators. Just be careful with the subtractions. So we have 1 times A is A. 1 times -2 is -2. We're subtracting 1. And let's solve this quick. So get your like terms together. -2 minus 1 is -3. No squared terms, so we just move your linear term to one side and keep your variables on the other. So 7 equals A. Quickly check to make sure that 7 substitute into the denominator doesn't make any of the denominators 0. So 7 squared is 49 minus 14. That's okay, it's not 0. It's A. If I put it in as 7, that's not 0, and the last one is not either. So A equals 7 is a good answer. If it's extraneous, just cross it out, or write extraneous, either one. Moving on. Alright, again, get like denominators. Or factor first, sorry, factor. So x2 plus 2, x minus 2 is the factor of the first. The second is x minus 2 already, so let's multiply by x plus 2. That way we have an x minus 2 as a factor and x plus 2 as a factor for each denominator. And then once you have like denominators, just drop the denominator and keep the numerators. So I drop the x minus 2, x plus 2 in the denominator, in this denominator. And now we have to solve. So we have to distribute to x squared to plus 2x plus 4x plus 8. I have 8 equals x squared plus 6x plus 8. And if we subtract 8, the reason why I'm doing that again, you have an x squared term, make it equal 0. Anytime you have an x squared term, make it 0. And 8 minus 8 cancel out. So now we look to factor. First thing with factoring is look for a greatest common factor. There is one. And then we look to see what. So make each factor equal 0. So x equals 0 and x plus 6 equals 0. And the first one, it's already solved. X equals 0. Nothing to get x by itself there. Second one, just subtract 6. So x equals -6. Go back to your original problem and make sure that x equals 0. Both of your solutions don't make any of the denominators 0. So x equals 0. 0 squared minus 4, that's -4. 0 minus 2 is negative 2. That's okay. So that's a good solution. And negative 6 squared. 36 minus 4, that's 32. That's fine. And negative 6 minus 2 is negative 8. So we're good there. Next one. So we have still solving. I gave you a lot of these problems so you can get better on it. At the more practice, the better you're going to get, as long as you're practicing in the correct way. So we have x squared plus x. First thing is always factor the denominators to see what you already have in common. So greatest common factor is x. Nothing to factor in the second term. Last term, nothing to factor. Now I look at what's in common with all the factors. I have an x and an x in the last. X plus 1 in the first, x plus 1 in the second, but not in the last. So it looks like x times x plus 1 is going to be my common factor. So if you multiply the middle fraction by just x over x, and the last fraction by x plus 1 over x plus 1, that'll give us x times x plus 1 on each denominator, leaving us with just our numerator. So we have x squared minus 9x plus 8 plus x equals x plus 7, or x minus 7 times x plus 1. You could multiply that out right there if you'd like. I don't like to do too much in one step, and it's not a big deal if you don't, because the next step is gather like terms and distribute there. So either way. So I have x squared gathering like terms. Negative 9 plus x is negative 8. X plus 8. And now here I'm going to distribute, so x squared. X times 1 is x. Negative 7 times x is negative 7x. Negative 7 times 1 is negative 7. See an x squared term, move all the terms. Well, usually it's move all the terms to one side, but in this case, the x squareds actually cancel out. So that's awesome. When x squareds cancel out, there's no more quadratic, so you don't have to get all the terms to one side. In this case, let's get all the x's to one side and your linear term to the other. So we have negative 6x here, so we're adding 6x to the left side, so that's negative 2x, negative 8x plus 6x. Subtract 8 over to the right, so that equals negative 15, and divide by negative 2. And x is going to equal 15 over 2, which is 7.5. You can keep it as a improper fraction. You can change it to 7.5. That's an exact answer, so we're good there. Either one. Substituting in 7.5 is not going to make it in the denominator 0, so we're good. That's the final answer. Awesome. Let's move on to 6F. Alright, Adriana can finish report in 3 hours. Tyler can finish the same report in 6 hours. How long will it take them to finish the report if they work together? Together is adding, so we're going to look to add things together. So first, we have the amount of work can be done is going to equal the rate times the time. The rate at which they work times how long they work. So the amount of work that's going to get done in this case is one report. A report, that's one report, and the rate or the time on each is different. So we have 3 hours as the time. So we have work, the amount of work that's going to get done, and we have time. So if we're going to have that, this general formula, let's divide by time. We don't know rate, so we know work and time on each one. So we have rate equals work divided by time. So in this case, we have Adriana. Her amount of work she's going to get done is one report over, and that's going to take 3 hours. Tyler, he can do one report in 6 hours. So the same report, 6 hours. How long will it take them to finish the report if they work together? So together, they have one report in, we don't know how many hours, T hours. So putting this all together, get Adriana's amount of work, so her portion of the work, plus Tyler's portion of the work, so his rate, so her rate plus his rate equals together's rate. So we have one report and over 3 hours, one report over 6 hours, one report over T hours. Keep the units all the same. So looking to solve this now, same as the last problems once you get here, is look at your common denominator. And it's going to be 6t. So to multiply the first fraction by 2t. Second term here by t over t. And the last one by 6 over 6. So that becomes 6t is the denominator of all of them. So let's just drop the denominators in. So you have 2t times 1 is 2t, plus 1 times t is t, equals 1 times 6 is 6. So you have 2t plus 3 is, or plus t is 3t, equals 6, divided by 3, and the time it's going to take them to finish is 2 hours. Does that make sense for our problem? Let's look back. So 2 hours. Well, if Adriana can finish in 3 hours, Tyler's going to certainly speed that up. Maybe he doesn't work as fast, but he's going to speed it up. It's going to be faster than if Adriana worked by herself. So 2 hours, that absolutely does make sense. All right, let's move on to the next problem. Vanessa's made 10 free throws out of 18 tries. So she would really like to bring her free throw average up to 68%. How many consecutive free throws should she make in order to bring up her average? So what do I think about here? So it's 10 out of 18. If she made one more free throw, she made one more, that'd be out of 19 tries. If she made one more than that, so made another one, that'd be 12 out of 20. And what am I doing each? I'm adding one to the numerator and to the denominator. We have no clue right now how many it's going to take to get to 68%. So that's going to be your variable. So let's go back to the original. We know she's already made 10 out of 18. We don't know how many more she has to make, but we do know by doing this quick little side problem here, is we add the amount of free throws she's making to the numerator and to the denominator. And we know overall we want her percentage to be at 68%, which is 0.68 as a decimal. And here's your equation set up. So, and I know you can do this without the equation. You can just keep on guessing and checking, but I want you to be able to do this by hand. So looking at getting common denominators, that's over 1. Easiest common denominator is 18 plus x. Always multiply the numerator by the same thing as the denominator. So in this case, we have 10 plus x equals 0.68 times 18 plus x. I'll run out of room here. And solving this, you distribute the 0.68 and subtract the, and put the x's on one side, subtract the 10 on the other side. Eventually you're going to get x equals 7. If you have more questions, please ask me, but that's going to be x equals 7. Moving on. Airplane can fly 500 miles with the wind. So we'll say the wind is coming from left to right. So an airplane flies, so the distance it flies is 500 miles with the wind, and same amount of time, that's going to be important, I believe, as it takes the airplane to fly 400 miles against the wind. So if I'm going against the wind, so that's if it flies to the left, this is if it flies to the right. So that's with the wind, against the wind. And so if the speed of the airplane is in still air is 300 miles per hour, so the speed equals 300 miles an hour. But it's not in still air anymore. If it's going with the wind is actually helping it. It's pushing it along to be at a faster rate. or faster speed. So we add the W, the wind. So W is the wind speed. And if it's going against the wind, unfortunately, the plane is actually going to be flying slower, so subtracting the wind speed. So we have distance and we have the speed. And distance equals velocity or speed times time. So that's another general formula. It's very similar to the other, work equals rate times time. The rate, which is speed, which is velocity, it's very, very similar. And the distance is the amount of work, that's the distance, that's how far the plane has to work to get there, or that's the distance of it. So anyways, we have distance and speed. So if we have distance and speed, let's get those both on the same side. And we get time equals distance divided by speed. So if you set each going with the wind with distance over speed and against the wind with distance over speed, and we say that the amount of time is the same on both, they're going to end up being equal to each other. So let's set up the numerator is 500 over 300 plus W, and that's the time to go with the wind, and 500, not 500, this will be 400 miles over 300 minus W. It's interesting, it changes color in the middle, and that equals the time. So both of these, this is the time it takes to go 400 miles. This is the time it takes to go 500 miles with the wind and against the wind. It says it takes the same amount of time. So this time to do this and the time to do that are exactly the same. So if time equals this, time equals that, then these have to be equal. So that's what we're going to do. And I'm going to do this down at number 14. And well, I'll have to erase it, but oh well. So 500 over 300 plus W equals 400 over 300 minus W. So you have a fraction divided by another fraction, or fraction equaling another fraction. You can do what you did in middle school and cross multiply if you'd like. I like to keep the same thing. So let's just get like denominators. Anytime it's an equation, get like denominators. And nothing. Easiest way to get a like denominator is multiply by 300 minus W and 300 plus W. So then we have 300 minus W and 300 plus W as your common denominator. So each denominator is a 300 plus W and a 300 minus W. And so those are common. Drop the denominators and look at your numerator. You have 500 times 300. And you can do this if you want to distribute, you can. I don't like to do too much in one step because then I tend to make more mistakes. Distribute now. 5 times 3 is 15 with 4 zeros. Minus 500 times W is 500W. 4 times 3 is 12 with 4 zeros. 400 times W is 400W. And now I'm looking to, there's no squared, so let's get all the W's to one side and the linear term to the other. And we should be able to solve. Just divide by the coefficient in front of the W. Minus 120,000. Minus 120,000. And we have 30,000 equals 900 W. Divide by 900. That's not 900. There we go. You get W equals 33.3, and that's the wind speed is miles per hour. They were talking miles and hours, so 300 miles per hour, so we just keep the same label. So 33.3 miles per hour is the wind speed. And this is how airlines figure out when planes are going to land, when they're going to get to each airport. So they do this all the time. All right, last problem. Working together, Kayla and Carlos painted a kitchen in 4 hours last year. Kayla painted the kitchen by herself. The year before, Carlos painted it by himself, but took 1 hour longer than Kayla did. How long did Kayla and Carlos take when each painted alone? And they paint this kitchen a lot. It happens. So we have 4 hours is your time. And Carlos took 1 hour longer than Kayla. That's Carlos's time. And what do we have else? Well, they're painting a kitchen. So that's the amount of work is one kitchen. And Carlos did the same thing, one kitchen. So we have work equals rate times time. We have work and time. So let's put what you have, put it on the same side. So we can make a ratio rate out of it. So the rate at which they work is rate equals work divided by the time. So we have Kayla. She can work, she can paint one kitchen in 4 hours, we don't know. I don't know how fast she can paint. So X. Carlos. He can paint one kitchen in the same amount of time as Kayla, plus 1 hour. So we have one kitchen in X hours, Kayla, and one kitchen for Carlos in X plus 1 hours. And we know together they can paint it in 4 hours. So together they can paint one kitchen in 4 hours. So keeping the rates the same. Kitchen over hours, kitchen over hours, kitchen over hours. So we have Kayla. The rate that she can work is 1 over X. The rate that Carlos can work is 1 over X plus 1. And together they painted it in 1 over 4 hours. So looking at getting like denominators, that's your equation. Set it up. We have X, we have an X plus 1 and 4. So X plus 1 is a binomial, so that these are not factors that are common. So we need to multiply, it looks like all the denominators by each other. So we have the first denominator is already X, so we need to multiply by X plus 1 and 4. So 4 times X plus 1. And I always multiply the denominator. I know we're going to drop them, but it kind of helps me see that I definitely have like denominators. Second one, multiply by 4x. And that's a binomial, so I'm going to put it in parentheses so I know to distribute this 4x in. And the last factor, the last term, multiply by x times x plus 1. And we have the first one, we have 4x times, or 4 times x, 4 times 1, and multiplying that all by 1, you get 4x plus 4. And then we have adding, so we have addition here, so it's not going to be too tricky. So you have adding 4x, and we have 1 times x is x times x is x squared, x times 1 is x. Drop your denominators because they're all alike. It simplifies it a little bit. I see an x squared term, so that means we got to move all the terms to one side. So we have minus 4x, subtract another 4x, subtract another 4x, subtract 4, and we get 0 equals x squared minus 7x minus 4. So we have, the reason why I moved all the terms to the right side is because x squared is positive. I always like to keep the a term positive. That's why I moved all the terms to the right side. Let's see if you can factor. So we have a term is 1. What two numbers multiply to negative 4 that add up to negative 7? Well, there's nothing. If that happens, factoring doesn't always work. We just have to use the quadratic formula. So x equals the opposite of b, so b is -7, so +7. -7, so that's b squared. I don't do any really math here, I just kind of write it all down. -4 times a times c all over 2 times a. And keep going with this. Next step is, all I do is I simplify the b squared, so -7 squared is 49. I do -4 times 1 times -4 is +16, so the sign will be +16. So I take it as a -4. And then 2 times 1 is 2. My next step, very simple, I just add the what's underneath the radical. 49 plus 16 is 65 over 2. You can look to simplify the square root of 65, and this is an exact answer. But when it comes to real world problems, I don't want a rational for an exact answer, because how long did Kayla and Carlos take when they do it separately? Well, this is Kayla's time, and that's a weird looking time. It is exact, but I would want you to actually do this in the calculator to get an actual decimal, so it's better, easier for us to see how long Kayla took. So doing this in the calculator. Alright, so alpha y equals the numerator 7 plus the square root of 65 divided by 2. You get 7.5, and then we also have the subtraction, so let's try that. Our alpha y equals 7 minus, you can get more than one answer, it's quadratic, so there are 2 solutions, so let's check them out. Over 2, and that's a negative. Negative hours doesn't make sense. Positive does, so we're going to go with that. So we'll just round it to 7.5 hours. So x equals 7.5 hours. Well, what did x equal? X equaled, all the way back up here, 1 kitchen over x hours. So Kayla can paint 1 kitchen in 7.5 hours. How long did Carlos do it? 7.5 plus 1. So 1 more hour. So this is Kayla. And Carlos can paint in 8.5 hours. So 1 more hour than Kayla. Those are your 2 answers. Okay, come to class with anything. Your test is going to be probably the next time I see you. Otherwise, I'll tell you in class. All right, thanks.